Hello, everyone. In this video, I'm going to go over kind of an interesting concept in SQL. There are types of queries that kind of defy logic in a way. And believe me or not, SQL is powerful enough to handle even that type of logic. This is something you're probably not going to see in standard SQL discussions where you can basically solve most of the queries that you're looking for with select from where, maybe a bunch of joins, bunch of where clause conditions. If you need to group things, you can use the group by clause. You can use different things like aggregate functions. But there are queries, logic that you cannot solve with any of these. So we're going to talk about that in this video. So the queries that I have been talking about, the ones that you can solve with standard select from where are called monotonic queries. And the idea of these queries are very simple, that you have some tables and you run a query and you get some output. And if you keep adding rows to these tables and run the query again, the output, which, as you know, in SQL, when you run a query, the output is always going to be in the form of a table. And the size of that output table typically will keep increasing as you add more stuff to the input table, right? That's the standard. That's the way we think things would work. But there are these types of queries for which it is possible that the size of the result may decrease as you increase the size of the input. Sounds very strange, doesn't it? Well, today we're going to look at a few of those types of queries. So we're going to take this very simple example of students registered for a course. So this is kind of the table set that we're going to be looking through. I'm going to keep these simple enough so that the logic is easy to understand. But believe me or not, even with something as simple as that, you can really do some fairly complicated queries. So let's take a look at some queries. The questions are going to be fairly simple. Like, for example, find students who never got an A in any course. Think about it. Students who never got an A. Is this monotonic? Can you add stuff to the input table and the results will disappear? Let's take out another one. Find students who have gotten an A in at least one course. What about this one? Is this monotonic? Non-monotonic? Not telling you now yet. We're going to look at it in a second. One more. Find students who have gotten A in all courses they have taken. What about this one? Is this monotonic or is this non-monotonic? Well, let's talk about it. Well, the second one actually is a monotonic query. Students who have got an A in at least one course. Well, think about it. If a student has got an A in at least one course, that student will be part of the output. Now, you can add whatever you want to that table, and that student is never going to disappear from the output because they've already got an A. And nothing you can do by adding rows to the input to prevent that person from showing up in the output. Now, remember, we're not changing anything, any existing data in the database. We're only adding more stuff. So now you're saying, well, by adding more stuff, is it possible that the output will disappear? Think about it. Let's take number one. That's the simple one. Find students who didn't get any A's. So this one should be easy to understand. So here, Mark is a student who did not get any A's. So Joe got one A, two B, Mark never got any A's, Judy got both A's, right? So if you run this query, let's say you figured out what this query is and you run it, Mark will show up in this output because Mark didn't get an A. Now let's say Mark takes another course. So we are adding a new row to this table. We're not changing any of Mark's grades. We're adding a new row with some other course, and this time Mark got an A. Now you run this query again, Mark will disappear, which means we just shrunk the output by adding a row to the input. As you can see, that is possible. Let's take another one. Find students who have gotten A in all courses they have taken. Well, Joe doesn't appear because Joe got some B's. Mark obviously didn't get any A's, so doesn't show. Judy got both A's, took two courses and got both A's. So Judy shows up in the output. Now, can you add something to this table and make Judy disappear? Yeah, right? So you can add Judy with some other course, and this time she gets a B, and now Judy will disappear from the output. Again, a non-monotonic query. So the question is, how do we solve these queries? Now, before I give you the answer to that, let's do a quick round of identifying monotonic and non-monotonic, and then we will talk about how do you solve some of these queries. Let's see how far we can go with it. So, for instance, we have already talked about these are the monotonic and non-monotonic. So if it is something is monotonic, you can solve it with basic select from where joins and things like that. But if it is query is non-monotonic, you're going to have to use something else. What we have seen in algebra, and if you know relational algebra, you know that there are a bunch of operations in relational algebra. And these five are the most important operations. If you think about it and just the way how these operations work, there's only one among these five that can do non-monotonic queries. And that one is set difference. So that is actually one really interesting clue as to how to solve non-monotonic queries. Now, set difference is not the only way to solve non-monotonic queries. And in fact, we are going to go over several different ways you can solve non-monotonic queries. Remember, SQL, a problem does not necessarily have a single solution. You can create multiple solutions to solve the same problem. So basically what this means is if you figure out that something is non-monotonic, you're going to have to use something like minus, and here are some of the other ones. Not in, not exist, pretty common. You can sometimes solve non-monotonic queries with some special grouping and maybe some left joins and things like that. But simple select from where is not going to work. Okay, so that's important to remember. Let's do a quick check to see, as we're doing, what do you think about these queries? Find the students who have taken some CS course. Is that monotonic or non-monotonic? Think about it. We're going to talk about the answers in a minute. Find the students who have only taken CS courses. What about this one? What about the third one? That's pretty interesting. Students who have taken all the CS courses. Many of you would think this was monotonic, but think a little more. It's a hint. Find the students who have not taken any CS course. Now, that hopefully is pretty obvious to most of you now. And this one is a little tricky because I put a little negative logic in there. Find the students who have taken a non-CS course. But turns out this one is actually a monotonic query. All right, so what's the answer to these five? The first one, students who have taken some CS course, if they have taken a CS course, they have taken it, so monotonic. Same thing with the number five, students who have taken a non-CS course. If they have taken a non-CS course, they have taken it and they'll show up in the result. But all of these other ones, number 2, 3, and 4, they are non-monotonic. So for example, the first one is the only, all, and none, right? So think about the only part. If somebody has only taken CS course, if they take another course from some other department, they stop showing up in the result. All is also same way. If somebody has taken all CS courses, great, but then CS department goes in and adds a new course. Now that the person who was previously had taken all CS courses drops out of the result. Obviously, if you never taken a CS course and now you go and take a CS course, then you drop from the results. So number 4, 2, 3, and 4 are all non-monotonic. They require different ways to solve, but um, identifying is the important part, that you should understand that these are non-monotonic. Number 5, as I said, is monotonic because although there is a non word in there, they have taken a non-CS course. It basically means they have taken a course where department is not CS. So it's a not equal to, but it's still a monotonic query. So here are some thumb rules. If a question has something like every, all, no, none, never, only, these types of words, maybe it will be non-monotonic. All right. But remember, these are just thumb rules. As I said, there was a question like non-CS course, that is a monotonic query. So sometimes just having a no or none or never does not necessarily mean it's non-monotonic. But these are hints that you could use to potentially think about whether it is a non-monotonic query. So let's do some queries, and I have a few in the deck, and I will, uh, you know, maybe talk about some of these queries in the deck. But let's just go into Oracle and solve some queries. So let's do a super simple one. Okay, let's say find students who have not taken any course. Okay? So this is one of the simplest non-monotonic queries you can find. Students who have not taken any course. Well, that means they haven't registered for anything, right? So if I take all the students and I minus or set difference students who have registered for something. If I take students who have registered for at least one course, something, if I take them out, then what the result is students who have not taken any courses, right? So let's look at several ways of doing this. So you have these types of things in your arsenal. So the simplest one is to, of course, to use minus, right? So find students who have, so select star from student. So that's all the students, right? If I run this, I'll get all students. Now, let's say I select s dot star from student s, inner join reg r on s dot sid equals r dot sid. Right? So I just did a join from registered with student with registered. That means the students we would get here are the students who registered for something. Okay? And if I run that one, as you can see, I'm seeing duplicates, but that's okay. These are the students who have registered. Now, if I put a minus in between and run these two together, now we see the student who did not register for anything. So this is the simplest way, or at least logically the simplest way to run a non-monotonic query. There are many other ways. Okay. Some of them are very similar to the minus. So for example, not in. The concept is the same. You want to find the students whose ID don't appear in any registration, right? Where SID not in, so The student ID is not going to be in any of the registrations IDs, right? So we will say select r.sid from reg r. I mean, we don't really need aliases, but as I said, I always like using aliases. So, okay. So basically what we are doing is I'm trying to find the students whose ID don't appear in the registration records. So if I run this, you'll see I'm going to get Tracy again. Now, there is another one very similar to not in, but that's called not exists. And this one requires something called correlated subqueries. Now, a correlated subquery is where you are creating an alias outside and you're referring to that alias from inside a subquery. This can get a little complex to understand. So if you do not understand this concept, you should be able to solve these queries with these other options. But let's talk about it. Some of you may get it pretty quickly. So what we're looking for is, and sometimes when I think about not exist, I actually like to say it out in English. Find the students such that there doesn't exist any registration for them, right? So select star from student S where not exists, okay? So what doesn't exist? There doesn't exist any registration in their name. So any registration would be select star from reg R, but they need to be on their record, right? So r.where r.sid equals s.sid. Notice that this s, this is why it's called correlated subquery. This s does not appear in this query. It's actually appearing outside. So that is actually possible to do. You can create a subquery where the subquery correlates to an alias that you have defined outside the query. You can't do it the other way around. You can't refer to something in the outside that refers to an alias inside, but you could do the other way. So now if I run this one, as you see, it works the same way. So all ways we're finding Tracy. So that's just another way to do non-monotonic queries. And this is not it. So I'm going to give all of the possible scenarios. So now remember that if you're looking for just doesn't exist something, or like this particular query, student who has not taken any courses, that means if I do an inner join, they don't get selected. But we know other types of joins where even if you're not correlated, you still get selected, right? And that's called a left outer join or an outer join. So let's see what happens if I do a left outer join. Okay, select star. We'll just say star for now. From student S left outer join reg R on s.sid equals r.sid. Let's just do the left outer join and see what that gives us. Okay. Now, as you can see, for all the students who have registered, you're seeing the courses that they have registered. But if I scroll down and down and down, there's Tracy. We know that she didn't register for anything because we ran this query before. And look what happens on this side. For their registrations, this part, which is coming from the registration table, is being padded with nulls. We can use that to find the people who did not register. So now we can say where r.sid is null. If I did that, then we get Tracy, just like before. And we can only say s dot star. That would also, but remember that this would only work if you use a left outer join. Okay, using left outer join. Now, while not necessary, here is another way you can count, right? Using counts. So let's say I want to find how many classes each student has registered, and obviously we want to find those students who have not registered for anything, which means their count will be 0. But in order to do that, you will still need to do left outer join. So let's just look at that for a second. Select s.sid. Let's say s.sname. Let's just that. And then count c.c number. Sorry, r.c. From, same thing. We still need to do a left outer join. This time I'm going to group by. Now if I run this query, so I'm doing a left outer join between student and registered. I'm selecting the student's ID name, and I'm counting the course numbers for each student ID. So if I run this, as you will see, that we're getting 3 courses for Joe, 2 courses for Jack, blah, blah, blah. But for Tracy, the number of courses is 0 because didn't register for anything. So now I can say, having count r.c number equals 0. So that's another way you can solve non-monotonic queries. Now, this one may sound a little more logical, although it's doing a little extra work to find the same thing. If they didn't register for anything, they will be null. Their SID will be null, but that might be logically a little difficult to grasp. But this one is easy. They have not taken any courses, which means the number of courses they have taken is 0. That's easy to at least logically explain. Now, remember that we needed to use a having because we are doing a condition on the aggregate, and you cannot do a condition on the aggregate in the where clause. You have to use the having clause for that. So these are all the different options you have. There may be other ones, like for example, a lot of times if you go to ChatGPT asking for solutions, it might ask you to do a CTE or common table expression. Common table expression is kind of like a view, like an inline view that you may have seen, but I don't always like common table expressions. They're just a little more messy, I think. But, if you like common table expressions, go for it. All right, so let's do a little more complicated queries. So for example, some of the ones that were in the deck. Let's take a look at students who got an A in at least one course. That's a monotonic query, right? So let's say students who got an A in a course. Okay. So this one, as I said, that this is monotonic, which means you can simple select from where works. Okay. So you could say select s dot star from student S, inner join reg R on s.sid equals r.sid, where they got an A, which means the grade is A. And if I run this, I will see students who got an A. So it's basically 1, 2, 3, 5, 6. Now notice that I'm getting duplicates. That's because they got an A in multiple courses. Simple, you could just say distinct. And that'll get rid of the duplicates. And basically you get 1, 2, 5, 1, 2, 3, 5, and 6. So it looks like 4 didn't get an A, and of course 7 didn't register for anything, so didn't get an A anyway. All right, so now let's reverse this and say students who didn't get an A in any course. All right, so now what you can imagine that if I find all the students and I take this out from them, then I should find the students who didn't get an A, right? So that's why I wanted to do the monotonic first. So now I can just say select star from student, and now minus this guy. So I take all the students and I minus the students who've got an A. Then what we would be left with is students who didn't get any A's. There you go, Mary and Tracy. Now, Tracy is a special case. Tracy did not register for anything. So obviously they didn't get an A. They didn't get any grades whatsoever, right? So sometimes, these are called default cases that show up because, they just, because it's a negative logic. So something that satisfies that negative logic will show up. So, and you'll see this in some of the queries that you do. Now, if you do not want Tracy, basically all you have to do is you could say that find students who registered for something and then take out the students who never got an A. So let's just say if you don't like the default cases, just do another join in here. So I will say, and just say student s inner join reg r on. That's it. Actually, I like to always use different aliases, although these two are not related. Notice that this is a minus, so these two queries are independent, but even then, I like to use different aliases. If I'm using two S's, you might get confused about which S it's referring to. But so that's why it's always good to use, whenever you're giving an alias to a table, use a different alias than one that you have already used in that query. So if I run this, what did I miss? R1. Oh, sorry. Actually, this is an interesting, important thing to remember, that the two things that you're doing a minus on, they have to be compatible. So I could not, so the reason why this failed was that, and I can run this. So if I run this one, as you notice that the error message was they have different number of columns. If I'm running this, I'm basically selecting stuff from both the student and the register. So I've got 1, 2, 3, 4, 5, 6, 7, 8 columns, right? But when I run this one, I only get 5 columns. So you can't minus this from this. They have to be what is called union compatible. You're not doing a union, but that's what it means. So that's why basically when you do union, intersect, and minus, you have to make sure that the two groups that you're doing it on, they're compatible. They should have the same number of columns. They should refer to the same things, basically. So if I'm doing all the students who registered for something, now I'm taking out all the students who registered for something and got an A. Then we will be left with only the students who registered for something but never got an A. So now if I run it, valid, oh, it's one dot star. All right, if I run this now, I get Mary, who did register for something but did not get an A. So Tracy is left out because Tracy didn't register for anything. All right, so let's try the not in here, okay? Again, using not in. So what we're doing is select s dot star from student S, where s dot sid not in. So basically, we're trying to find the students whose ID does not appear in a registration with a grade of A. So select r.sid from reg r, where r.grade equals. So it's basically finding all the students where the IDs don't appear, any of the IDs in the registration where the grade is A. And this will give you, again, as you can see, Tracy shows up because, as I said, Tracy is the default result. And you can do the same thing. You can just have another inner join outside to take care of the where is it? Not exists works the same way. You could say this where not exists. What does not exist? Any registration for that student with a grade A. So we'll say select star from reg r, where r.sid equals s.sid. So you see how I'm now correlating this query with that, correlating this inner query with that outer alias, and r.grade equals. Again, we get Mary and Tracy. All right, so now let's go to a little slightly more complex, but you will see it's really not that complicated. So let's just say this one, find students who have gotten A in all courses they have taken. So we've done this one, we've done this one, let's do this one. Find courses we have got all A in all courses they have taken. What does that mean? If you think about it, you can actually answer this in a double negative, right? Sometimes it's actually easier to think of a logic in double negative in order to do it in SQL, because SQL has that not in or not exists, which is basically a negative, and you put another negative inside. But basically, if a student has gotten an A in all courses that they have taken, that basically means that they haven't gotten anything other than an A, right? So everything that they have taken is an A. So all we have to do is, so let's say, find students who have got an A in all courses they took. That means students who did not get any grade that is not A. Right? So did not get, that's where the not exists, and the grade is not A. So let's try that. And you could do this with minus and not in and not exist, all of them. It works the same way, but essentially all you're doing is, whether you do the minus or let's do the minus. All we have to do is we basically say where grade is not equal to A. So basically all the students, and we're taking out the student who got one registration with something other than an A. Now if I run this, I get Pat. Pat got all A's. Now look at that. This. Tracy shows up again, right? Now, Tracy didn't take any courses, which means Tracy never got a grade that's not A, right? So that's why I said default results are sometimes a little weird. So sometimes you just want to get rid of them because in the previous query, it sort of made sense to have Tracy there because, the question was asking students who didn't get any A's, and Tracy didn't get any A's. Now, this one is asking find students who have got all A's, only A's, right? Well, Tracy didn't take anything, so she never got any non-A's, but that doesn't totally mean that she got all A's. So this is where it might make sense to take out the default. And it's pretty easy. Just do a join outside, and that'll take care of the default. So if I do this, and instead of just selecting all the students, I only select the students who have taken something. And now if I do the minus, I will only get Pat. Tracy goes up. So that's essentially how it works. And in the same way with a not in or not exists as well. Okay. So let's quick recap. How do you solve non-monotonic queries? Idea is that you should first recognize that it's a non-monotonic query. That's the first step. And once you recognize it, you have many different ways. You can do a minus. That's the first step. Sometimes it's hard to express a query with a minus, right? But you can. If you can express it with a minus, sometimes that's an easier thing. Remember that the two things that you're expressing as minus, sometimes one of them might be another non-monotonic query. Okay. In fact, let's do one. Now, this one is going to be fairly complex, but let's look at this one. Find students who have only taken business courses. Now let's think about it. This is obviously a non-monotonic query, right? If we're looking for students who have only taken business courses, which means they have never taken a course that is a non-business course, right? So how do you solve this? So let's say I want to do with a minus, okay? You can. So you could say find all students. And what do you need to take out from all students? We're looking for students who have only taken business courses, right? Now we have to take out students who have taken something other than business courses. Actually, this one is a lot easier. Since we talked about it, let's solve it. I was actually thinking of a different query. But this query turns out to be easy. Minus students who have taken something other than business courses. Okay. And turns out that this one is a monotonic query. So now I got two monotonic queries. I put a minus in between and I solved the query. So let's just go ahead and do this, and then we will do the one that I was thinking about that is a lot harder. So select star from student S. And then minus, select S dot star from student S, inner join reg R on S.id, equals r dot sid. I need another inner join. C dot C number for C on R dot C number equals C dot C number. Okay. And basically students who have taken something other than business courses, which means this courses department where C dot department is not equals business. So we're looking for something other than business courses. So the department is something other than business, which means department is not equal business. Now, if I run this, I will see students who have taken all the business courses. Is there one like that? Oh yeah, it looks like Jack and Mary have taken all business courses. Only taken business courses. They may not have taken all the business courses, but let's just see, maybe Jack and Mary have also taken all the courses, right? So let's select star from Reg. Let's see who are the people who have taken all the business courses. I just want to see if there is anybody who have taken all the business courses. Now let's just select this, and so we can see everybody. I'm just gonna do a select star. The full join between all three tables. And let's order by C dot department. And S dot SID. I want to see who have taken all the business courses. All right, let's see. Joe has taken, looks like database and programming are the only business courses. No, intro is CS. So database and programming are the two business courses. And Joe has taken both of them. Jack has taken both of them. Jill has only taken one. Mary has taken both of them. And Peter also has taken both of them. So 4 people have taken all business courses. So Jill is the only one who haven't taken the business courses. Now, out of that, Joe, Jill, and Peter and Pat, they have taken other courses from other departments. So the first query, Joe, Jill, Peter, and Pat is not going to show up from here because this query is asking students who have only taken business courses, which should be only Pat, no, not Pat, Mary, right? Yeah, because Jill has taken a CS course. So Mary is the only one who should show up in this query, who have taken only business courses. Oh, Jack shows up as well. Let's make sure. Maybe I did not notice. Jack has taken business courses. And at the bottom, that's right, Jack does not show up here, which means Jack did not take any CS courses, so they have taken only business courses. So that's good. So this query is correct. Now, let's go to the more complex one that I was talking about. This one is a lot more complex. That's because I want to find who have taken all business courses. Okay. Now, this one is a little more complex. Why? Because we can go the same way. We can say this is basically all students minus, right? I want to find the students who have taken all the business courses. What does that mean? I want to find the students who haven't, for whom there is, no other business course to take, right? So there is no business course for whom there is no registration for that. So turns out if you're doing a minus, that second part of the query is also a non-monotonic. So by doing a minus, we try to make sure that both sides of the minus are monotonic. But when this happens, then you are stuck a little bit because now you're going to have to think about a little further. How do you uh, figure this out? Now, um, there is a preferred version that I have, which is basically using a double not exists. And that could get a little tricky to think about. So what we are going to push this minus a little bit. Um, Find students who have taken all business courses minus, so sorry, find students, which basically means find all the students. And I want to take out the students for whom minus students such that their um, their ID so there is no course for which there is no registration for them, right? So basically, what are we taking out? Taking out the people who have not taken some business course. So students who have not taken some business course, right? So that's basically what we're trying to do. Students who have taken all business courses is basically all the students, and we take out students who still have at least one business course that they haven't taken. Right? But this one is still a non-monotonic. So you can try to do another minus. That could get complicated. So ideally, if you have like a minus and a minus, I suggest that the second query try to use a not in or something like that. That makes it a little easier to understand. So all students minus, I want to find the students who have not taken some business course. So let's get that some business course. So notice that student and course you can't join because they are, they're not related. But we want to bring that in so that we want to say that there is no that registration does not exist. So here is a course in the business department, and I'm saying that this student does not have a registration in that department. So now, and s.sid not in from registration R, where, so we look for all the registrations in that course, R.C number equals C.C number. We're still correlating because not in, unfortunately, only works for a single thing. You can only do a single attribute not in a list of attributes, right? So that's why we can't, not exist would have been better. But now let's say if I run this query, just that one after the minus, this should give me students who have at least one business course to take, right? So Jill has something to take, Pat, something to take, and obviously Tracy didn't take anything. So now if I do the minus, I get those four, Joe, Jack, Mary, and Peter, who have taken all the business courses, right? So as you can tell that this is a double non-monotonic logic. With not exists, we would have done it like this. Select, pretty similar. Select dot star from student S, where not exists. C dot star from for C, where C dot department equals business, and not exists. That's where the dude second not exist comes in. So now we're trying to find the students where there's no course in the business department for which there is no registration for that student. So that's kind of the logical way of solving this query. This would do the same thing. We will get those four: Joe, Jack, Mary, Peter. But notice that it requires a double not exist. So when you are working on queries and you notice that there is a non-monotonic logic, think about how complex this non-monotonic logic is. If you can express it as a difference between two sets, and it works out that both of those sets are monotonic, you're golden. That'll be easy to do. You can do it with the minus option or a simple not in option. And if you like not exists, once you do a few not exists, you will get used to it. The difference between not in and not exists is when you say not in, you have to provide an attribute that's not in, and the inner query needs to select those attributes. With not exists, you could do not exists, basically say select star, but then you're going to have to correlate the inner query with the outer query. So that's the main difference. Practice a few with data sets and see if you become an expert in non-monotonic logic. Hope that helps, and hopefully I'll make other videos on SQL as well.